Hi, good afternoon, ladies and gentlemen. Today we're going to be talking through some required practicals for the AQA GCSE, Trilogy, Synergy, and the Chemistry specifications.
So the required practical we're doing is Chemistry, it's required practical 3, and for the Trilogy it's required practical 9, and it is Electrolysis. So there's two methods. I'm going to do the one with the electrolysis cell. Mr. Reed's going to do the one that requires just a beaker. So we're going to both do copper chloride as just a way to show you the similarities and differences between both of the methods. So for the one with the electrolysis cell, you're going to need a clamp stand with your boss and clamp on it, and then firmly affix your electrolysis cell. You can see it's got the two built-in electrodes here. So you just don't make it too firm, because this could smash, and you don't really want that liquid going everywhere. So just quite firm, make sure it's stable.
And what are the electrodes made out of?
These electrodes are made of carbon.
Diamond's also made out of carbon. Are they diamond electrodes?
These are not diamond electrodes, no, because they've not been under enough pressure for a long enough amount of time.
So which allotrope of carbon are they?
Graphite.
Graphite.
So graphite.
Superb. So graphite conducts electricity, does it?
Graphite does conduct electricity, sir, yes.
Superb.
Why does it conduct electricity, sir?
I believe because each carbon is only bonded to three others, so there's a free delocalized electron that is able to move through the whole structure, carry the charge.
Cool. So on the end of each wire we're putting as crocodile clips, and you can see these electrodes are coming all the way through this rubber bung to the bottom, so we're attaching our crocodile clips underneath and into our power pack. The power pack is not switched on yet because we don't want the electric current going through as of yet. The power pack is on 12 volts. We are going to add in our copper chloride solution. So for the electrolysis cell, you want to fill it up to just over the spikes, leave yourself a bit of room, because when we add in these tubes full of copper chloride, it's going to displace, and we don't want too much of it spilling everywhere. So these tubes are very thin, they've got a very small diameter, so when we fill up with the copper chloride solution, you can see on the top there, we've got a little bubble of water coming up and over, and because of the water tension, that should be able to hold when we flip it upside down and put it over the spike. Can do that again. We'll use a beaker for better pouring.
We made a mess.
Yeah.
So we're currently we're not locked down as of yet, are we?
Not as of
yet. We
not
currently
as of
need to obey the 2 metre rule, socially isolating because of coronavirus.
We're not isolating. Distancing.
Distancing, yes.
Distancing. Making sure lid goes back on copper chloride. Don't want it to make more of a mess. Okay, and that is pretty much this method done. All we need to do now is switch on the power pack, and if you want this to just see if you can get something going, if you slightly lift up your little tubes, you should see just a bit of bubbles going on. Mr. Reed, do you want to show your method?
Okay then, so you may see that in your exams. You might also may see it this way. Okay, and we're just going to use a beaker. I'm going to start off, we're going to be measuring out. Shall I do the same, copper chloride first?
Yeah, do copper chloride so compare results.
So I'm going to measure out a volume, okay? I'm going to use 50 centimetres cubed, my measuring cylinder, make sure I'm doing it at eye level. I'll transfer that into my beaker, okay? Lovely blue coat copper chloride. Next, I'm going to use my power pack. Now I'm going to connect the red wire into the red and the black wire into the black. Okay, this is to help us so that we know the red is positive and the black is negative. And I have to connect them to 2 crocodile clips. Or are they alligator clips?
Gators.
Gators.
Just gators.
2 graphite electrodes. Now it's important that the electrodes do not touch when they go in the solution. So I've made this little device, and I can just slot the electrodes in there, and it will keep them separate, keep them touching each other.
Why is it important that they keep separate?
We want the current to run through the solution, and if they are touching, the current's just going to run through the electrodes. Okay, so we won't have electrolysis happening. Electrolysis is, we can split that into two words. Electricity, and lysis is Greek for separating, okay, to break apart. So we're going to use electricity to separate the ions in the solution. So, right, I've got potential difference of 4.5 volts. I've got my power pack turned on, and the light is on. And then we can see that bubbles are starting to form at one of the electrode, and at the moment I can't see anything happening at the other electrode. Okay, so the black wire is negative, and that's connected to the negative electrode. Okay, the negative electrode is called the cathode, and the positive electrode is called the anode. Now the way I remember that, I use a little acrostic style device, and I use the words panic.
Did you say mnemonic? Mnemonic, maybe?
Could do. Mnemonic. Is that what it is? Should we go see
An anagram? An anagram?
Not an anagram.
An acronym.
An acronym.
Acronym sounds
An acronym.
better. I don't know. It's a thing.
So, positive anode, negative is cathode. Panic. Positive anode, negative is cathode. Okay, now I'm going to look back, observe, and I can see there is a colour change happening at the electrode. That's a black wire, which is negative, so there's a colour change happening at the cathode. Okay, and that's going that lovely distinctive pinky, orangey, browny colour, and I know that copper is forming there from the copper chloride. And then the bubbles, okay, there are produced, I know that's chlorine gas. Okay, chlorine gas. Now, the chlorine ions in solution are negative. Okay, so they're going to move towards a positive electrode, which is the anode. Okay, and they're going to donate some electrons, lose some electrons to become two chlorine ions going to become two chloride ions are going to become chlorine gas, Cl2, and the copper is going to, which is a 2+ ion, is going to gain those two electrons to form the pure copper metal. Now, the one way we could do it to test if this is chlorine, okay, we could actually do the litmus paper test. Okay, so we've got some damp litmus paper.
The better experiment to be doing this with, the better investigation, where we can't really collect the chlorine gases easily from there, but these are in little tubes, so the gas has displaced the liquid, so you can see the liquid going down. So it might be difficult to see from where you are, but the liquid has gone out and has been pushed out by the gas. So, as Mr. Reed said, the negative chlorine should have moved towards this positive electrode.
Negative chloride ion.
Has moved to the positive electrode. So if we take the positive electrode, there's some gas in there. It's best to wait till it's all run out, but hopefully if we turn this the other way up and let the gas move back out, you can see there's the gas being trapped there. If we turn it that way and hold the litmus paper above, you can see it goes red first, and then the chlorine gas bleaches the litmus paper white. So your colour change for your litmus paper would be red, then white.